welcome to True Projects. In this video, we are going to explain about the project, which is YOLO, ESCA, a high performance safety helmet standard wearing behavior detection model based on improved YOLO V5. Before getting into the execution, first let us understand what is the project about. The construction industry really has to deal with a lot of safety risks. The work is labor intensive, process often overlap, and also the environments can be pretty tough to navigate. One of the key things we rely on for is safety is helmets. They are absolutely essential for preventing injuries. However, there is a significant issue with how they are used. For example, a lot of workers doesn't fasten their chain straps properly, which can lead to serious injuries, especially if there is a fall. So there are safety standards like GB 2811 2019 that specify how helmets should be worn to provide maximum protection. But many workers are just not aware of these standards or don't follow them. So you can see how that's a problem. Traditionally, we would rely on manual monitoring to ensure compliance, but the method is really inefficient. It takes a lot of time and also the resources, and honestly, it is not very effective. That's why there is a growing need for automated system that can detect whether workers are wearing their helmets correctly. Automating this process could make a huge difference in keeping everyone safe on their job site. So deep learning has made a significant strides, especially in single stage object detection models like YOLO, which is you only look once, which show great promise for real time monitoring. However, most existing models only check for the presence of a helmet without ensuring it is worn correctly. They also face challenges such as high computational demands, which can be an issue on the construction sites, and they often miss detections or struggle with the small and partially obscure targets. So, to tackle these issues, we need an improved YOLO. So, we need improved YOLO based model specifically designed for standardized helmet wearing detection. This model would not only verify that helmets are being worn, but also enhance overall safety in construction environments. So, to tackle the issues that we have discussed, this project introduces an upgraded version of the YOLO that is called as YOLO ESA. So, it is specifically designed for checking whether the workers are wearing helmets correctly in the construction sites or not. What's great about this model is that it operates in real time, which means it can automatically detect if helmets are being used properly. So, coming to this YOLO ESCA, it uses some advanced techniques to boost its accuracy. For instance, it employs efficient intersection over union, that is EIOU. So, this is the loss function which helps the models to make better predictions. And it also includes soft non-maximal suppression, that is soft NMS, which helps to reduce false positives and also the false negatives. So coming to the convolutional block attention module, that is CBAM, is used to better focus on the important features of the helmet and the worker's head. Additionally, there is a small target detection layer that enhances the model's ability to recognize helmets at various distances and also the sizes. Overall, the system is tailored specifically for the construction safety, making it much more easier to ensure that helmets are being worn correctly in the real time. Moving on, as the part of the extension, to further improve the detection accuracy as the extension, we have incorporated the other advanced models of the YOLO version, which are YOLO V5X6 and as well as latest YOLO V8 and YOLO V9 models. So this upgrade is aimed at boosting accuracy of object detection and enhancing our overall performance analysis. In addition, we built front end using Flash framework. So this makes it possible for users to test the model directly and provide secure access through authentication. Essentially, this means that users can easily interact with the model, allowing for testing and analysis in a way that is straightforward and user friendly. This setup not only makes the technology more accessible, but also helps ensure that it can be effectively used in the applications. Moving on, to implement this project, we have followed the steps in the flow of work. So first, we have imported the required packages. Here we will be importing required libraries and packages. And then we will be loading the data set, loading the images from the data set into memory for processing. Then we visualize the images to understand their structure and content, which aids in the subsequent processing steps. Then the Then we process the images. So here we transform the image into a blob format, which makes it suitable for the model input. Then we specify the coordinates for bounding boxes that will enclose detected objects in the images. And we ensure that the image is in a format that can be easily manipulated and processed by NumPy. And the next step is we will be loading the pre-trained models. Here we will be accessing the architecture of the neural network to understand its structure. Then we will identify which layers will provide the output predictions for the detection task. And we do further processing of images to ensure that are ready for the model. So we annotate the files, we combine the images with their respective annotation files that contain labels and also the bounding box coordinates. And we change the color format of images from BGR, that is blue, green, and red, to RGB, that is red, green, and blue, which is typically required by the most models. And we generate masks that identifies areas of interest within the images. And we adjust the image dimensions to match the input size expected by the model. Then we do further data augmentation. So this step enhances the data by creating variations of the existing images which can improve the model robustness. Here we introduce some randomness to the dataset to ensure the model learns to generalize well. And we change the orientation of the images to simulate different viewing angles. And we apply various transformations such as flipping or scaling to increase the dataset diversity. And then we ensure that all the necessary libraries and dependencies are installed and configured for the project. This involves preparing the data specifically for using the YOLO models, which may include formatting annotations and adjusting image data accordingly. In the next step, architecture of the YOLO model is constructed and configured based on design parameters for the detection tasks. Then the model is trained using the prepared dataset where it learns to recognize and detect the objects of interest, that is, safety helmets, by adjusting its internal weights based on the training data. Once the model is trained, the model that performs best on the validation data is saved for future use in the detection tasks. And a web interface is created using Flash framework, which will allow users to interact with the models through a browser. Then a user authentication features are implemented to ensure secure access to the application using SQLite database. And the front-end interface utilizes the trained model to classify and detect safety helmets in uploaded images. Moving on, users they will be uploading images in the web application for analysis and detection of safety helmets. That image will be pre-processed at the backend and it will be fed with the trained model for detection. Finally, the detection will be displayed in the front end. Moving on to the algorithms used, these are the algorithms used in the project to detect the safety helmets. So these are the extension models and this is the proposed model. Moving on to the requirements. To implement this project, we need basic requirements which are hardware and software. So coming to hardware requirements, we need operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. Coming to software requirements, we need application of Anaconda, primary language of Python, front-end framework of Flask, back-end framework of Jupyter Notebook, database of SQLite, and front-end technologies are HTML, CSS, JavaScript, and Bootstrap 4. Now let's execute the project. To execute, we need to open the code folder which contains source code files. Let us open the code folder. So these are the source code files in the code folder of a project. Let us understand them. So in these three folders, we have the dataset used in the project. Coming to sample folder, in this we will be having the test cases that we will use in the front end to detect safety helmets. Get back. Coming to the static folder, this folder consists of files related to CSS, JavaScript, and Bootstrap files, which are important for the visual appeal of the project. Coming to templates folder, this folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. Coming to app.py file, this .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in HTML templates. And here we have model file. So this contains the algorithm information. This will be loaded into the project code during runtime of the application. And here we have notebook.ipynb file. This is a Jupyter notebook file which contains a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells making it a popular choice for the data science. And here we have signup.db file. This file is a database file which is used to store the user information. Now in the starting three folders, I told you that we have dataset, right? Let's open the first folder, that is YOLO v5 folder. So here we have two subfolders, one is train and the other one is valid. So let us open the train folder. Here we have two more subfolders, one is images and the other one is labels. Let us open the images folder. So here we have total 798 images. So these are the construction site images. These we will be using to train the models to detect the safety helmet, whether the persons are wearing helmet or not. If they're not wearing, it will detect one type of detection, or else it will give that they're wearing helmet. Get back. So in this label folder, we will be having file and file annotations, that is annotation files. So these are the annotation files or the label files. So these are the label files for the objects in the corresponding images. So here each label file contains the object locations. So these files, they corresponds to the image files in the image folder. For example, this image file, this annotation file corresponds to the first image in the images folder. Similarly, for the second image, we will be having the second annotation files. So these annotation files, they provide the object locations and localities of the objects in the image. So these provides the object locations and classes within the image. So these label files, they follow the YOLO format. Let us open a file. Let's open it. Here, this line represents a detected object. This follows a YOLO format. So here, each line specifies the object class index. This is the object class index, followed by its bounding box coordinates. This is the X limit, this is the Y limit, this is the height, and this is the width. So this is the detected object in the image number one. Let's close this. Similarly, we will be having in the 798 images, 798 annotation files. So for all the 798 images, we have 798 annotation files. Get back. In the validation folder also we'll be having the images and labels. We will be using the images which are in the train to train the models, and the images which are in the validation folder to evaluate the models how they have been trained. Get back. So accordingly, we will be having in the YOLO V8 and YOLO V9. In this two folders, we will be having the same images, but they are annotated differently because each YOLO version requires its own specific type of image annotations for training and testing the models effectively. Having separate folders helps keeping the dataset organized, ensuring that each YOLO version receives the correct annotations it needs to function properly. So now let's execute. To execute, we need to copy the path of the code folder from the address bar of the file explorer. So I'm copying the path. Now open the Anaconda prompt. It is open. Using the command cd followed by the space, paste the copied path. Now click on enter. So here we have not copied it completely. Let us copy it again. Get back to the Anaconda prompt. Use the command cd followed by the space, paste the copied path. Now click on enter. So here if you observe, current directory is changed to the code folders path. We need to copy the path correctly. So here if you observe, this number 17 is missing. So we need to copy the path correctly. So now give the command python space app.py and now click on enter. This will change. This command, it will execute Python script and perform runtime check for any syntax errors or logical issues. After running the app.py file, Flask framework will host the application locally at the default address, which is the local host and the port, unless configured differently. So now we will be getting the link. So this is the local host and this is the port. Now we need to copy this local link provided by the Flask framework and paste it in any web browser. So I'm copying the link. I prefer Google Chrome and I'll paste it in that. Paste the link here, click on enter. This is the web page of the project, which is displayed in the browser, and this is developed using Flask framework. So first we need to click on register and enter all the registration details and get registered. If you are registering newly, I have already registered, so I'll directly sign in. Click on sign in and give your username and the password. Click on login. We have logged in successfully and we are redirected to detection page of the project. So here you can see a choose file button, right? We need to click on that for uploading the images. So let's click on that. So these are the test cases of the sample folder. Let us upload the first image. Click on open. Image has been loaded. Now click on upload. Image will be processed at the backend and then we will be getting the prediction. So here we can observe that there is a detection. Here it has detected as uncertainty with a blue color bounding box with a 0.93 probability score. 0.93 probability score. Probability score is nothing but it's a confidence level that how accurate the detection is in detecting one particular object. So it is 93% correct that it detecting uncertainty. Here it has detected as uncertainty because he's not wearing the helmet properly. So that is why it is detected as uncertainty. Let's try using some more. Let's try with this image. Here if you observe, there are two detections, that is helmet with a 0.94 probability score and with a 95 probability score, and they are drawn in the white color bounding box. As they are wearing helmets properly, here it is detected as helmet. If they're not wearing properly, it will detect as uncertainty. Let's try with some more. So now let's try with this one. So here if you observe, we can see there are three uncertainties detected because they are not wearing their helmets properly. And here we have the highest probability scores. Get back. Now let's upload this one. So here if you observe, there are two detections. One is helmet and the other one is head. Here he is wearing helmet. That is why it is detected as helmet. That of 0.94 probability score. So this person is not wearing helmet as well as, he's completely without the helmet. That is why it is detected as head. He has to wear the helmet. It means that he has to wear the helmet. Here we have probability score of 0.93. Get back. Click on choose file. So let us upload this image. So here if you observe, there are two uncertainties detected because they're not wearing the helmets properly. Click on choose file. Let's try uploading this image. So here if you observe, there are four helmets detected because those people are wearing helmets and they have worn it properly. They have kept the belt properly. So that is why it has detected as helmet. And there are two persons without the helmets. That is why it has detected as head. Get back. Click on choose file. Now we will upload this one. So here there are two uncertainties and two helmets because two people are wearing helmets properly and the other two are not wearing the helmets properly. Let's try with the last image. So now let's try uploading this one. So here if you observe, there are many people detected with the uncertainty and only with one certainty, that is helmet of 92 probability score. Let's get back. Now we will check with the graphs. So click on graph. So here we have precision and recall graph of YOLO model. And here we have FN score graph, where on x-axis we have confidence level and on y-axis we have FN score. And here we have confusion matrix of the YOLO. Here on the x-axis we have true instances and on y-axis we have predicted instances. This is the precision comparison graph. Here on x-axis we have precision score and on y-axis we have algorithm names. And here we have recall comparison graph. Here we have MAP comparison graph. MAP, precision and recall are the error metrics used to evaluate the detection models. So now let's click on logout. In this widget, by uploading construction site images to the system, the YOLO model, it will accurately detect whether the person is wearing helmet or not. If he's wearing helmet, it will check whether he is wearing properly or not. If he's not wearing properly, it will detect as uncertainty. If he's wearing, it will detect as helmet. If he's not wearing at all, it will detect as head. So this will help the workers of the construction sites and also it will ensure the safety of the people who are working in the construction sites. So this is all about the project.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, Please visit Through Project's YouTube channel and subscribe.